Early Warning System Drought and Climate Outlook webinar. This is the first webinar we're having in 2017 of a bi-monthly webinar series that we will continue throughout the year, and is an activity of the California-Nevada Drought Early Warning System. So Amanda, you want to go to the next slide? My name is Alicia Mars. I'm the Regional Drought Information Coordinator for NIDIS, the National Integrated Drought Information System. We're a NOAA program, but we do have an interagency mandate from Congress to help coordinate and help disseminate drought and climate information across the nation at an interagency level. So we work together with our partners at all levels of government and nonprofits, universities, and in the private sector to help provide better access and better understanding to drought and climate information so that our stakeholders and partners can better adapt to the impacts of drought. You'll see on the map on your screen that we are piece by piece assembling a national drought early warning system by creating regional drought early warning systems. So this is an activity of the California-Nevada DEWs, drought early warning systems, what we affectionately call as DEWs, so you'll hear throughout the day. You want to go to the next slide, Amanda? So a little bit of background information on what a DEWS is before we get into the webinar. Essentially, a DEWS is a large partner network. We're utilizing existing networks and then hopefully creating new informational and collaborative networks throughout this sub-region of the country. The California DEWS was one of the first established by NIDIS in 2010, and we've recently expanded it in 2016 to include Nevada as well, again, as we start creating a national network of drought early warning systems. Essentially, the DEWS is assembled to help make climate and drought science more readily available. We support research, we support capacity activities so that stakeholders and partners can better access that information and also learn how to use that information. And then it also involves monitoring, forecasts, and drought planning and adaptation exercises. Drought obviously can span many different spatial and time scales, so there are a lot of pieces to this puzzle as we figure out how to better adapt to the impacts of drought. One of the cornerstones of what the California-Nevada DEWS is working on right now is the development of a strategic plan. That's an activity that's been ongoing for the last 6 months or so and should hopefully be finalized in the coming month or so. So stay tuned for more information on that. If you're interested in other activities that happen within the California-Nevada DEWS, you can always go to drought.gov. You'll see the website listed below. And there's more information on some of the research projects and some of the other activities and workshops that are underway in this region. I'm going to hand it off to Amanda Sheffield, who is with one of our key partners with CNAP, to explain their role and some of their activities.
Hello, everyone. As Lisa mentioned, I'm with the California-Nevada Climate Applications Program, and key to these DEWS networks is connecting and working with groups that are on the ground in these areas. I won't give you too much, but we're basically climate information for decision makers in California and Nevada. And just we have some upcoming things, including seasonal forecasting 2-pagers, which is a type of product that we produce, and we also have a winter status update coming up on February 9th in San Diego. To get back then to today's webinar agenda, obviously it's been an exciting time for weather and climate here in California and Nevada. We're going to hear from someone from the Western Regional Climate Center first about the drought and climate status update, and then move to some National Weather Service Office service hydrologists for their river and reservoir status, before moving into the outlook portion of the talk, also from the National Weather Service, and then actually a topic of snow drought, which these storms recently have been great additional snow resources that we've had to the snowpack we've had so far. So it's been an interesting discussion of how the snowpack has evolved with this season. With that, I'm going to pass it over to Dan McAvoy, who's with the Western Regional Climate Center.
And before Dan starts, this is Alicia one more time. Just a reminder that all of the slides from this presentation will be available on drought.gov, as will a recording. And we will send an email directly to all of you with a link to that, but you can also find it by going to drought.gov and searching under the calendar, where you can find access to similar resources from other workshops and webinars as well.
Thank you, Alicia.
Okay, thanks, Alicia and Amanda. Can everybody hear me and see my screen now?
Yes.
Okay, great. All right. Well, I'm going to give everybody a bit of an update on what's been going on since the last webinar, which was early December. And it's been, as Amanda mentioned, a very active time period, both December and January, but especially January, as I'll talk about. And this is a photo from the Squaw Valley Alpine Meadows Twitter account, just showing how buried the ski resorts were up there. This was January 12th, and there's been a whole other series of big storms that have just added to this snowpack. So I want to start off sort of with the big picture of the drought, which of course is the U.S. Drought Monitor. This is the most recent map that was last updated on January 17th. So there may be additional changes coming this week. I can't say for sure yes or no yet if that will happen, since there's been a lot more weather over the last week. But just in general, we've definitely been seeing improvements. Northern California is completely out of drought status. A lot of Nevada is out of drought status, and really the places that are still in this D3 and D4 are Southern California, the coastal regions into the southern Sierra Nevada. And I'll talk a little bit about why those regions may still be in this D3 and D4, even though we've been seeing quite a bit of heavy precipitation over the last few weeks. Now, if we actually look at the changes that have occurred in the drought monitor over the past 4 weeks, so this was the change from December 20th to January 17th. And so anything in green is improvements in the drought monitor. And so we've seen these widespread 1 to 3 class improvements in just a 4-week time period. And for the West, that is really huge to happen that fast, and just says a lot about how much these recent storms have contributed to improving the drought. And so the biggest improvements really have been in the Sierra Nevada, the central and Sierra Nevada into the western part of Nevada, where up to 3 classes of drought improvement have been found in the past month. So why have there been all these improvements? Well, let's start off with the easy question, the precipitation that has occurred basically in this water year. So the water year runs from October 1st through September 30th. And so the map on the left is showing basically the first 3 months of the water year, October, November, December, the percent of normal precipitation. And so if we focus in there on California and Nevada, it was a really pretty good start to the water year all around. October was extremely wet. November was kind of average or a little dry in some places, and then December was pretty good as well. Of course, there's a few pockets of below normal precipitation along the coast of California into the southern Central Valley and parts of western Nevada. But overall, a lot of the state is near average or a little bit above average, going from October 1st through the end of the year. Now on the right is the map just for January, and this was updated this morning, January 1st through January 22nd. And pretty much, the entire state of California and almost all of Nevada has seen a ton of precipitation, well above normal. Much of the state of California is seeing 200 to 400% of normal precipitation for the month so far. There are some pockets of even higher amounts of 400 to 800% of average for the month. So a very, very wet January so far has really aided in some of this drought amelioration. So I threw this in last minute because we showed that Southern California near the coast was still in D3 and D4 categories. So these are the 3-year precipitation totals, the percent of normal from January 23rd, 2014 through January 22nd of this year, 2017. And there's still huge precipitation deficits when you consider the 3-year totals. The percent of average along the southern coast, California is still below 50% in some places, 50 to 70% of average. And these 3-year precipitation metrics are definitely heavily used in the Western U.S. Drought Monitor classifications. And so, the Drought Monitor authors definitely look at these 3-year totals. And so this is part of the reason why the Southern Sierra and Southern California may still be in that D3 and D4, is because of the long-term precipitation deficits. And so, we've had a very active December and January, and there's been quite a few atmospheric river storms that have really helped, bust this drought. And there's been some research showing that, single events or a handful of atmospheric river storms can really act to completely end droughts along the west coast of the United States. This is a nice graphic that I took from the Center for Western Weather and Water Extremes homepage that's produced down at Scripps. I'm not going to go into the details of this, but they're basically talking about, showing a very strong atmospheric river that occurred early in January that contributed a lot of rain and snow to the region. And so there was really 3 big storms. There were some other smaller ARs that occurred as well, but the big ones were December 9th, 10th, December 14th to the 16th, and then the really, really massive one was January 7th through the 10th. So these have been extremely helpful in helping to improve the drought conditions over the western U.S. So of course temperatures definitely play a role in the drought too, especially with snowpack, as I'll show. So these are the temperature anomalies now. On the left I'm showing December 2016, and then on the right is January through the 22nd. One thing I wanted to point out is even though we had quite a above normal precipitation over a lot of the state, California and Nevada, in December, the temperatures were actually quite warm during these atmospheric river storms, which is common to have above normal temperatures during atmospheric river storms due to the warmer origins of the air mass from the tropical regions. But you can see on the left, the Sierra Nevada was above normal, through a lot of December, especially during these individual events, 2 to 4 degrees Fahrenheit even in some cases. And January was a little cooler. The northwest part of California and Nevada were quite cool, but as you go further south, things got a little bit warmer. So I want to briefly talk about in the next few slides how these temperatures have affected the snowpack that we've seen here. And so these are the percent of normal snow water equivalent from the SNOTEL network. Unfortunately, the SNOTEL reading network was down this morning, so I couldn't get the most recently updated graphics. This one is from January 19th, and even from at point of January 19th, it looks from the broad perspective that the temperatures have not affected the snowpack all that much, because these are really impressive percent of normal snow right now, getting close to 175, 185% of normal in the eastern Sierra and western Nevada, and then still very good as you go out across the eastern basins in Nevada, well over 100% of normal. So this is really good shape, the snowpack right now. And then of course, these are the data from the California Department of Water Resources that focuses on mostly on the Sierra Nevada and the southern part of the Cascades in Northern California. And so the Sierra Nevada snowpack is doing really well right now. Statewide, 168% of average, 86% of what we would normally see at April 1st, which is really impressive. Very good snowpack right now. I want to highlight the southern Sierra is at 197% of average and 95% of the April 1st snowpack. And this is really huge because the southern Sierra hasn't seen a really good snow year in a number of years. Even though last year the northern Sierra did all right, somewhere around average, maybe slightly above average, the southern Sierra still did not do very good. So this is big improvements for the southern Sierra. Very good to see. This is a graphic I took from that the National Weather Service Reno put together, just showing how much the snowpack changed from early January to mid-January. Basically, the top graphic is showing it went from about 60 to 90% of average. That was on January 2nd, before the first big series of storms came through. And the lower graph is showing the snowpack increased to 195 to 200% of average from January 2nd to January 13th, which is just huge. Those numbers are really impressive. The High Sierra saw 9 to 15 feet of snow. So January's just been, again, really impressive and helpful for the Sierra. But I wanted to get into a few localized stations and show what was going on. As I mentioned the temperatures before. So this is a graph from the Tahoe City SNOTEL at just below 7,000 feet. And what the graph shows here, the red line there is the normal 1981 to 2010 median snow water equivalent, so the snowpack accumulation from throughout the water year. And then the gray line is the normal precipitation accumulation throughout the water year. And of course the blue line then is what we've seen this year in snow water equivalent, and the black line is the precipitation. And a couple things to point out. At these low elevation stations, as I mentioned, the temperatures were warm in December, and so the snowpack was doing okay in early December, and then came along these warm atmospheric river storms and basically washed out all the snow below 7,000 feet. As you can see, the precipitation curve still accumulated a lot of precipitation in December, and the snowpack dwindled. But you know, we're not even noticing that now, since January has been so huge that, you know, the current SWE is above 15 inches, and the normal on April 1 is, you know, about 12 or 13 inches. So we're above the April 1 average. The precipitation is well above the full water year average. The normal is about 36 inches, and you know, we're getting close to 45 inches already. Now at the higher elevations, this is from Mount Rose ski area in Nevada on the northeast side of Lake Tahoe at 8,800 feet. Pretty much the same story, except if you look at the December time period, the snowpack grew pretty much above 8,000 feet. They didn't see nearly as much rain at the lower elevations, or at that elevation, and so you can see the December snowpack accumulated instead of shrank. And you know, the precipitation numbers there I don't think are right at the end of January, but you know, the snowpack is showing again well above the April 1% of average. So just very good for the drought, these big snowpack numbers right now. Briefly, I want to talk about the reservoirs. These are the California reservoirs. Basically, these bucket diagrams showing, you know, the full capacity of the reservoir, and then the percent of average for where we are right now. A lot of the reservoirs, particularly in the north, are you know, near average or above average. It's pretty variable though. There's still quite a few, especially as you go down south, that are, you know, below average for this time of year. And you know, these reservoir operations, they all operate differently, have different restrictions when they can release water, store water. I'm definitely not an expert on the reservoir operations, but they don't always fully reflect what has recently happened, you know, in the weather and climate. But in general, the reservoirs are getting a lot better and doing a lot better than they were last year. And I also wanted to highlight a couple reservoirs that aren't on there in Santa Barbara County. Again, this is partially why they're still down in D3 and D4 down there, is that the reservoirs down there, Kachuma Reservoir and Twitchell Reservoir, are still very low, you know, 11 and 4.8% of capacity. And so, you know, it's improving slowly, but, you know, they're still not doing great with water resources down in the southwestern part of California. This is a graphic showing the Lake Tahoe elevation, going all the way back to October 2010, when we had our last really big winter in the region. And you can see it basically going down, down, down each year with the 5 consecutive years of drought. The red line I've put on there is the natural rim of the lake. And this is basically, if it's below that level, there's no water flowing into the Truckee River. And so we had a long stretch there where the Tahoe was below the rim. It came up last summer for a while and then went back down, but now it's well above the natural rim again. It's currently at 5.08 feet as of this morning, and so that's already higher than it was at its peak the last 3 summers. So this is really huge for water supply for northwestern Nevada. So this is a very good sign for the drought. And one more figure. This is something that Mike Dettinger provided. He's been making these graphics, I think, the last few years, basically showing the combined reservoirs plus the snowpack and where that stands as, you know, a percent of normal. This is compared to the 2000 to 2015 normals that he uses. And you can see the gray shading is the reservoirs plus snowpack average, and then the blue is just the reservoirs only. And so this was through January 15th. And you know, the thick yellow line, or the thick orange line, is showing the reservoirs plus the snowpack this year. This is from a bunch of different sites along mostly the Sierra Nevada. So the reservoirs plus snowpack are well above the normal for this time of year, and also the reservoirs statewide are a bit above normal for this time of year. So that's encouraging. So I'm just going to wrap it up with a few key points here. Definitely the drought conditions have been really improving thus far, thanks a lot to December and especially January. Southern California is still digging out, but their conditions are improving. We don't even have the data from the past 24 hours in a lot of those plots that I've shown, but they've gotten a lot more rain down there in the past 24 hours, so it's starting to improve. Still a few unknowns. We don't know what's going to happen the rest of the year. We've seen this a number of times before, where we have a wet early winter, and then things dry out really quickly. So the weather and the moisture can turn off just as quickly as it turned on. We hope that doesn't happen this year. And then, of course, there's the issue of groundwater, and we just really don't know what's going to happen, how much this is going to help the storage and the recharge, and so that's also a big unknown. And that was all I had, so I guess we'll save the questions for afterwards.
Thanks, Dan. Actually, while I'm changing presenters, we had one quick question. It was, has the ridiculously resilient ridge finally dissipated? I didn't know if you had any details you could add here while I'm switching screens.
I think the easy answer to that is this water year, it definitely has. It's definitely hasn't been there. We've had a pretty consistent stormy pattern, going back to the beginning of October. So yes, it has currently disappeared.
Okay. Thank you, Dan. Now I'll pass it on to Cindy Matthews, who's with the Weather Forecast Office in Sacramento, and Tim Bardsley, who's with the Weather Forecast Office in Reno. And they're going to give us a little more details and a localized perspective on the river and reservoir status.
Good morning, all. This is Cindy. My graphics shadow a whole lot of what Dan gave us just a few minutes ago, but I think some of mine I checked in after he did, so I've got some updated graphics. What you're seeing on your screen is December 31st snow water equivalent percentages or normal to date for snowpack for Northern California. And on the right hand is as of midnight last night, or yeah, they do just after midnight for that. So you can see that in the last month, these January storms have done a big improvement to conditions. Northern Sierra is at 88% of the April 1st snowpack. That is, April 1st is usually the max of the snowpack around here. Central Sierra is up to 99%. We haven't seen levels like that since 2011. And Southern Sierra, 121% of normal. That's a big deal. They have been especially hard hit in the last 6 years of the drought. So statewide, we are at 104% of the April 1st average statewide. But I want to caution you, just like Dan did, there is a lot that can happen between now and April 1st for that pack. If we get a really windy spring or end of the winter, you can sublimate a large percentage of the pack going up there, and none of it rolls off the hills. And it is not unusual for California to see a dry month or month and a half in the middle of the winter time. We've had a wet December, a wet January. Looks like the rest of January is going to be dry. Cross our fingers that February is not dry. So let's go on to the next slide, Amanda, please. Here's an updated version of the graphics that Dan was showing you. As you can see, the historical average line is pretty close to the point at which these reservoirs along the foothills of the Sierra start to become encroached into their flood control space. So the bigger reservoirs like Shasta and Oroville, not Folsom as of today, but Don Pedro, are making small to moderate flood control releases out of the reservoirs. So they're actually having to make room for the runoff that's still coming down the hill. And as we get later into the spring, they're expecting that inflow for those from the melting snowpack to help top off those reservoirs in the springtime. So we'll see some things. We have not seen these blue bars this large in many, many years. As Dan pointed out, there are a few that are still relatively low. New Malona is only at 66% of its historical average, but some of those are up much higher than they've been since 2011. Something to remember, precipitation in California is a big deal. It helps fill the reservoirs for surface water runoff type stuff, but a large percentage of the Central Valley cities and municipals and in the foothills and the mountains do not depend on surface water for their water supply. There are huge areas and large populations that depend on groundwater supply. Groundwater conditions as of yet have not yet stabilized, and we have not seen any increases in groundwater levels up to this point. That's a slow refill process, so it may be some months before we see improvements in certain locations. Let's move on to the next slide, please. Amanda asked me to talk about the river conditions. This is the front map from the California and Nevada River Forecast Center. And for California and Nevada and Southern Oregon, they forecast 98 forecast points. Currently, we are in much better situation than we have been the last couple of weeks. Only 22 of those, the orange dots, are above monitor stage, which means there's some localized flooding happening, nuisance type flooding, and there's some actions being taken by the local levee maintaining agencies like levee patrols and such. And we're down to only 2 of those locations being above flood stage. Most of the rivers, especially in the north, have already peaked from last night's rain and the Sunday rainfall and are on their way down. They're the faster responding rivers in California. The further south you go, down the Central Valley, the slower the response is. So we still have some rises coming for the next 4 or 5 days possibly there. And in Southern California, you get back to those really fast responding ones. Our locations down in San Diego County, those will peak by tomorrow morning. So conditions are improving, but we are still seeing large runoffs from area rivers, streams, and creeks out of the Sierra and out of the mountains into the valley. Next slide, please. And what you're seeing here is our snow water equivalent improvements for California and Nevada from the NRCS. And Tim, do you want to take over from here?
Yeah, sure. So this graphic, unfortunately, the legend on the left only goes up to greater than 14 inches. And as Dan mentioned, there's this issue today with the SNOTEL data. But some of these sites are actually up to 30 inches of snow water equivalent this month. So that's pretty enormous. And I think about 7 sites in the Central Sierra of the SNOTEL sites are at their record for the date as of a couple of days ago. And that's with about 35 years of record. About another 7 or 8 of the SNOTEL sites are at their second highest. When you look at basin-wide, they're most of these, they're not quite in record territory basin-wide on my side of the on the Nevada and Eastern California portion, but they're getting pretty darn close. So they're in the top 2 or 3 years of the past 35 years basin-wide. Okay, go ahead, next slide, please. So this is just an example, and unfortunately this is as of the 19th, that black line showing the snowpack condition, and Dan had one of these for a single site, but this is for the 8 sites of the Truckee River Basin. That's increased a bit more and is sitting there just a bit below that blue line, which is the maximum, but is sitting above the April maximum SWE. And most of these east side, and Cindy showed some numbers for the California as a whole, but on the east side, pretty much the Carson, Walker, and Truckee are all in excess of the normal April maximum SWE. Okay, next slide, please. And this is just a snapshot, and this is a bit repetitive of some of Dan's, but in the upper left is the January 1st. So you can see, and Dan had a nice slide. He's looking at, I think, Tahoe City Cross, alluding to this early, even as of January 1st, the low elevation snowpack was not very impressive. And that was keeping, and the high elevation snowpack was not particularly impressive either, but it was very, very poor in the low elevations. That has changed dramatically, and these numbers are actually a bit biased towards the high elevation sites because there are not a lot of low elevation sites. But the low elevation snowpack, certainly on the east side, I can't speak as well to the west side, but it's pretty enormous. Towns are having issues, mountain towns, Mammoth Lakes and Truckee and places like that. They're having a lot of issues related to huge snowpacks and power issues and roads and where to put the snow, and there's a lot of challenges involved with that. And go ahead with the next slide. I don't want to, please. Oh, and then in terms of water supply forecast, this is as of a couple of days ago. The River Forecast Center in Sacramento does daily updates, and you can see these volumes are pretty huge. You'd have to zoom in to get specific, but they're in the 150 to 300% on the east side, and kind of in the 120 to 160% or so on the west side. You can also take a look, and I didn't have this graphic here, of the kind of observed flows to date, and most of those are, at least I don't know that I do. Go ahead to the next one and see if I have that there. No, oh, no, I don't. So the observed flows to date are very large as well. We're in the on the east side in the 200 to 400% of normal. So October 1st till January 23rd, how much volume has gone down compared to normal. And some of the rivers, like the Truckee and River, has over half of its water year typical volume has already come down downstream. So this is more water than we saw in total water year in 2015 on many of the rivers on the east side. So it's a pretty big change. I did not have a chance to put a reservoir graphic for my side. Cindy talked a little bit about reservoirs on the east side, and Dan talked about Lake Tahoe, which has been pretty impressive, having come up almost, I think, 1.8 feet this month alone. But reservoirs on the east side are improved dramatically. We don't have quite the nice graphic that the California Division of Water Resources does, but on the Truckee and Carson, we're pretty much at right at average right now for those basins. The Walker River is at 150% of average for this time of year, and the Lake Tahoe is now up to 68% of average for this time of year, down from just a couple months ago being below the rim. So some pretty huge improvements, and that's all I have.
This is Cindy again. I'd like to comment more on the water supply volume slide that you're looking at. These are the natural flow runoff volumes from the pack up above the reservoirs. These do not translate directly to water allocations from our major water supply reservoirs. Currently, the state of California has allocations at 40% of a normal water year, even though we know there's a huge snowpack out there. And the Bureau of Reclamation doesn't even make their water allocations decisions until we get closer to that April 1 number. So just because there's a lot of snow up there does not guarantee that all the water users down the Central Valley, Sacramento Valley, San Joaquin Valley, and into Southern California will get 100% of their allocations. That's something we're still waiting on.
Good point. Thanks for bringing that up, Cindy.
All right, thank you, Tim and Cindy, very much for that informative presentation. Next, we've been looking at here the current status update, but now we're going to move into, let's look into the future. And I'm going to change it over to Andrea Baer, who's with the Western Office of the National Weather Service, and she's going to give the most recent outlook.
Thanks, Amanda. Let me pull this up here. Thinking about it. There we go. Okay, good morning, everyone. I'm going to talk to you a little bit about where we are with this waning weak La Niña, and the little bit I can tell you about the climate and drought outlooks going into the future. So this map I have up here is just the sea surface temperature anomalies. That's just showing our weak La Niña event during the season of October, November, and December. So just a little recap of that. I'm going to give you the summary slide now in case you fall asleep and don't remember anything else. But we are still in La Niña conditions. We do still have a La Niña advisory out, our Climate Prediction Center does. The sea surface temperatures in the equatorial Pacific are near to below average. And we do expect a transition to El Nino is starting to happen right now. Or excuse me, to ENSO neutral. Oh my gosh, I didn't mean to say that. So we're transitioning from La Nina into ENSO neutral as we speak. And that should continue definitely through the first half of 2017. So looking back at other years, there were 7 other years where we started out the calendar year with a strong El Nino, and then and basically what you can see from this, I know these are very faint lines, so hopefully you can see those pretty well on your computer, but this is kind of what happened during those other years. And you can see there's a plethora of different outcomes that happened. And I think this is a good slide to demonstrate that we don't always know what we're going to get during El Nino or La Nina times. We don't always, we can get tendencies, we can get ideas of typical situations, but if you think about it, there's really only been 8 other instances like this one, if you count all those lines, since 1950, and that's not a huge sample size to do a lot of studying with. So I think, you know, we need to look at La Nina and El Nino to help us see what our range of possibilities are. But I think we need to be careful also when using that information to look into the future. The last 2 graphics I've shown you have been a recent blog on NOAA's ENSO blog, and that's on the climate.gov website. And there's usually about 2 entries on that blog a month, and it goes through and talks about what's currently going on and puts things into as simple of a perspective as possible for such a complicated phenomenon. But I recommend you kind of checking back at that every now and then to get yourself caught up with what's going on with ENSO. It's a really good way to do that. So keeping with history here for just a minute, what I'm showing you now, this just shows you at the bottom in this yellow highlighted box where we are. We're definitely, we've been experiencing a weak La Nina that is definitely waning. It is likely that the November, December, January number is going to come in above or below that negative 0.5. So this will probably classify as a weak La Nina event. If you don't get 5 of these in a row consecutively, then we really don't consider them a La Nina event or an El Nino event. So we're waiting for those January numbers to come in, and then they'll probably call it, you know, a weak La Nina event. So looking at what's been going on the past month in that equatorial sea surface temperature area, you can see that temperature anomalies were near to below average across the central and the eastern Pacific, above average near South America. So definitely starting to wane. And here's just another example of the waning. So the weekly sea surface temperature departures are at negative 0.2. So as you can see, starting to move away from that 0.5 region back up towards neutral territory. And the ocean also shows that the subsurface temperature anomalies since March have been persistently in the negative range. And then starting about November, they started that trend upwards back towards neutral territory. So looking at the ENSO forecast, so this, whether or not we're going to have El Nino or La Nina, as you can see what I had mentioned before, these green bars indicate that ENSO neutral is definitely favored, especially for the first, well, probably first 2/3 of the year. But what I want to point out here is some hints starting to show up in our models that there could also be a chance of El Nino developing as we move into the fall. Now, we're not getting too excited about this yet because it is just it's very, very early. It's only January, and there are just hints of this. But notice the most favored category is ENSO neutral. So just starting to pick up on El Nino possibilities, and definitely La Nina going away and being less of a possibility. So just wanted to throw that out. It's a possibility. It's a hint. It's not something that you should go and get excited about quite yet. We've got a long way to go. And this is the actual model output from all of the dynamical model tools and the statistical model tools that are used in looking at and predicting ENSO. And as you can see, a lot of them stay in between this negative 0.5 and 0.5, so in this neutral range, but a few of them do venture up later on as we move towards fall into that El Nino range. So again, something for us to keep a watch out for. And as we move into the seasonal outlooks, I do have to say there's not a whole lot of information for California and Nevada. And that's indicative of, you know, there are not a lot of, there's really not a lot going on with ENSO, so that takes away that forecast of opportunity. So we're really left with long-term trends, soil moisture, what's going on in our dynamical models, and there really isn't anything that's giving the forecasters at the Climate Prediction Center that strong confidence of either above or average or below average precipitation, with the exception of the April, May, June season, possibly some drier conditions in Northern California. But one thing I do have to point out and want to point out is that the precipitation that you guys have had in California and Nevada really wasn't picked up well in our models, in our seasonal models. So you have to use these with a grain of salt. It is the best that we have right now, but I think you know, it is questionable to use some of these forecasts at this point in time. It just didn't pick up on this recent moisture that has been going on the past 2 months. So just something to keep in mind. And I would look at, of course, your local weather forecast office information, the River Forecast Center information, and from the Climate Prediction Center, keeping up with the 8 to 14 day outlooks. Those week 2 type outlooks is probably a good way to go during these times when there just isn't a whole lot of information that we can provide forecast-wise for the seasonal timescale. And then moving into temperatures, you can see the Climate Prediction Center is still, as we're getting through this waning La Niña ending, they're keeping a cooler signal up in the Pacific Northwest, but really not a lot of information temperature-wise through these first 2 seasons for California and Nevada. A little bit of a nod towards, or a tilt towards warmer than normal conditions expected for the April, May, June season. But again, you know, don't bet the farm on those forecasts. I think, you know, definitely pay attention to the other forecasts coming out of the Weather Service as well. And then looking at the seasonal drought outlook, this was issued late last week. And as you can see, with the forecasts and with what's going on with current conditions, the Climate Prediction Center is still expecting drought to persist. It could remain but improve in this area. It took 5, you know, and a half, almost 6 years to get into this drought. So yes, it's been very wet and it's been very beneficial. But as Cindy and Dan and Tim all mentioned, you know, we really do need to wait to see as we move further into this water year, and those April 1st numbers are going to be key. So yes, it's exciting and it's great, but I think everyone needs to be cautiously optimistic and cautiously celebrating because it's not quite time yet to do that for everybody. And then with that, I won't repeat my summary slide. That's all I have for you guys for the outlooks.
All right, thank you, Andrea. At this time, we have some questions coming in, but we're going to save them for the end, and then we'll try to answer as many as we can in the time that we have. Before we do that, we have one more presenter who's going to talk about the snow drought, which is interesting to talk about right now because obviously the snowpack's doing relatively well, but it shows how important certain storms can be to the actual amount of snow that we have. And Ben will talk about that in recent years as well.
Okay, so can you guys all see and hear me good?
We can't see your screen yet, Ben.
Can't see the screen. Can you send me the link again? I thought I clicked it. Sorry.
That's fine. I'll take it back and then I'll send it back to you real quick.
Okay. Okay, how's that?
Yes, we can see your screen.
Okay, cool. Get this going. Okay, well, I would like to share some recent research findings and thoughts that Dan and Britta and Nina Oakley and I have been considering over the last few years as we hopefully are now exiting a persistent drought period. And that corresponds to an idea called snow droughts, which is a concept that's come up fairly recently, mainly in the Pacific Northwest in response to large departures from normal of precipitation, but anomalously low snowpack at the same time. And the last couple of years have shown in our region some very interesting temporal evolutions of how snow droughts can start and end. And I just wanted to share a few thoughts on some of the things that we're thinking about regarding those. So how to define snow drought, it's really, if you look in the literature, there is not a lot out there except for what's been happening in the recent years, where we've had these below average snowpacks but above average precipitation. And a lot of the recent research is really focused in the Pacific Northwest. And of course, being in California and Nevada, where we're highly dependent upon snow water resources, or snow-derived water resources, we thought it would be valuable to explore how this works in our region as well. And so an emerging definition that's still open for discussion, and I'd definitely be interested in hearing how others of you think this should be defined. Most of the previous studies have focused on April 1st and using an examination of snow water equivalent and its relationship to the median or average snow water equivalent for that point in time, typically the characteristic maximum in snow water equivalent. And so we're using less than 60% snow water equivalent at April 1st and requiring that precipitation is greater than 100% of normal or median for the water year. And so where we're going to be focusing is in the central Sierra Nevada, northern Sierra Nevada, this red box here, so highlighting the Lake Tahoe Basin and some of the watersheds in that region, notably the Yuba and American and Truckee River watersheds, as well as getting down into the Cosumnes and McCallamy, Carson River as well. And so what we've been using, we've been linking together snow courses, which are the little green dots on the map. And those are nice because they have longer periods of records. We're able to look back. In the Mount Rose case, we can go back much further. But most of these are focusing on 1951 to present, and then we're also using SNOTEL data from the past 37 or so years. And the nice thing about the SNOTEL data compared to the snow course data is that SNOTELs you have at times hourly, although there are some issues with the quality control that need to be dealt with, but the daily values of precipitation and snow water equivalent and temperature are very useful from the SNOTEL, whereas the snow courses are much coarser in time, because those are collected usually around the first or so of every month. So we have a monthly time step with the snow courses, but a long period of record, and we have a daily time step with the SNOTEL data, but the period of record is not quite as long. And this definition of snow drought we think is really important in how we can actually assess the impacts on hydrology and ecology of these snow-dominated watersheds at different characteristic elevations, both during the cool season and during the subsequent runoff or warm season. In this photo here, you can see Matt Church, who is not quite 6 feet tall. This is a photo taken near Castle Peak on April 3rd of 2016. And you can see that as he's skiing along, the snowpack is quite a bit lower than the characteristic height of the moss growing on the trees, which is kind of a nice little indicator of where we should expect the seasonal maximum of snowpack to be. And this year, or that year, 2016, had precipitation at this point in time that was about 115 to 120% of normal, but the snowpack was much, much below its normal April 1st value at this time. And how that changes the hydrology of these watersheds is pretty unknown at this point in time. We know that a reduction in winter snowpack changes the timing of runoff during the warm season, and it also changes the magnitude of subsequent warm season base flow as well, both of which are important for water resources for human consumptive use as well as the ecosystems. And something else that's come up recently as far as an interesting potential impact of snow drought is that for the critters of these snow-dominated watersheds, the low snowpack in the springtime can actually make it really difficult for them to do their thing, and that's something that we're also kind of looking into, collaborating with some biology-minded folks in these watersheds to explore some of the impacts of that. So some examples of snow droughts in the northern Sierra, if we use our definition are 60% of April 1st snow water equivalent and periods of time where we have above average precipitation. This is based off of the snow course data and PRISM output. We can see that any of the colored dots that fall within that snow drought quadrant in the upper left-hand side, you can see that you are typically below average SWE and well above average precipitation. Interestingly, in 2015, the gold or yellow dots is what we would consider more of a proper warm drought. It's a snow drought in the sense that there was almost no snowpack at this point in time, and that's been fairly well studied at this point. But the precipitation was also fairly well below normal values as well, and so we've been kind of focusing a little bit more of our efforts on the wetter snow drought types where we have the above average precipitation but well below normal snow water equivalent. So each one of these dots represents a different snow course, and you can see for certain years you get a pretty wide spread. 2016, the teal dots or cyan dots, for example, shows that some stations were well in the snow drought regime, and some other stations, or sorry, not stations, snow courses in this case, were actually in a fairly good situation where both precipitation and snow water equivalent was above average. And in some years, there's a strong elevational dependence, but in other years there is not, and that's something that we're exploring to kind of understand the impacts of the snow droughts on the given watersheds. So a few problems exist with this April 1 definition, and one of those comes down to the fact that singular events, like one large storm event, particularly early in the season, and we thought we were kind of going that direction this year, as I'll get to in a few minutes, can really kind of skew the results that you may end up with. And so what we've been working on is trying to provide a cautionary tale on evaluating snow droughts in a climatological context, and then how to use those cautions to better evaluate the risks of future snow droughts. So we'll take a quick look at 1963, water year 1963, the green dots, and you can see that those fall in large part in that snow drought quadrant. And that year was really a good indicator of how valuable it is to check how a season unfolded. And some of you may remember the Great Columbus Day storm of October 1962, which was a wonderful atmospheric river storm. On the right-hand side, you can see the October 1962 precipitation percent of the 81 to 2010 normals, and you can basically see the pathway that atmospheric river took and provided greatly above normal precipitation for that month. That really shifted the outcome of the water year. If we look in the bar graphs, or kind of the block graphs in the upper part of the figure, we can see that looking in the middle, the precipitation for the rest of the year was below to pretty near normal. It was really October that was very, very, very wet, and that really pushed the percent of normal precipitation for the water year up. Temperatures were near to slightly above normal. During February, it was a little bit warmer. And moving to the right, we can see that we started off with a lot of rain, didn't have a very good snowpack. The dry and a little bit warmer December and dry November through January really kept the snow water equivalent below average, and there was a little bit of recovery in March. But by the end of the water year, or at the peak measurement time, you can see that the single event in October, the Columbus Day storm, really drove us towards a snow drought, and that would kind of hide some other impacts of an otherwise broadly dry year overall. Another issue that comes up when you only look at one time, the April 1 time, means that you're only going to see one state of this system. And 2016, the teal dots again, provided another really nice example of that. And this is an interesting year because certain snow courses did quite well April 1st, but some of the lower elevation ones really did not do so well, and those were well into the snow drought regime. So if we look at the Tahoe City SnowTel, and I apologize for the really busy graphic, I will do my best to walk you through it. We can see, looking at the green line first, that's the accumulated that's the snow water equivalent through time, starting at October 1, which is the first day of the water year. And you can see that that line tends to be above the black line, or the median snow water equivalent, for much of the year, pretty much through January. And we can see with precipitation, the gold or orange dashed line is well above the black dashed line, which is the median accumulated precipitation. So we're off to a really good start. And then a persistent dry and warm period during February, those two flat areas in the gold dashed line, really started to do some damage to the snowpack. And you can see that at that point, the snowpack, which was above average, has now fallen off, and there's a large divergence away from the median snow water equivalent. And so we've gone into snow drought starting in the middle of the year. There was a little bit of recovery in March, but those storms were fairly warm, so that recovery was somewhat muted as well. And so looking at the snow levels during each of these events can really kind of tell us the story of how the snow droughts will evolve in time. One last problem that exists is using the single time also means that you might miss the story of the snow drought and how it's evolved and impacted the winter. And we can use this current year as an excellent example of going in and out of snow drought. And Dan kind of mentioned this in his presentation. We started off doing pretty well as far as water goes, but we were having a really hard time with snowpack accumulation. This is a medium elevation snow-tall site. This is the Central Sierra Snow Lab site. Snow levels during the start of 2017 were very much higher than the long-term normals, and that really drove this lower elevation snow drought where we had a lot of precipitation but very little snowpack accumulation. We briefly exited from the snow drought in December, but then we fell back into it after a few more warm storms really pushed the snowpack back down to below average and continued driving us into a well above average precipitation. Then January came along, and we had a very wonderful active wave pattern that took place during the end of the end of December into January, and we had a really big rain event. There was substantial impacts from that most of you are probably well aware of. Luckily, we had enough snowpack that it was able to absorb a lot of that precipitation, and that really drove us back up out of the snow drought situation. And then that really wet, warm storm was followed by several excellent colder storms that produced some really fantastic snowpack recovery. And so now we are well out of snow drought. But to reiterate what's been said several times before is that we know now, having come through 5 years of persistent drought, that things can turn off just like they turned on, and a prolonged warm and dry spell through February into March and April could really deplete our snowpack quite significantly, and we could still go back into a snow drought. Hopefully that's not going to happen, but it is a potential, and we should keep our eyes out for that. So a few concluding remarks. This definition is still kind of arbitrary and in progress, so we're happy to hear what you think about ways to improve it. Exploring the origins of snow droughts can give us some insight into both the process that creates them and leads to their demise, as well as some of the hydrologic and ecological impacts both during the cool season and during the subsequent warm season. A few storms or a persistent dry or wet period, as we've seen, plays a really important role in how snow droughts begin and how they can rapidly come to an end. Something else we've been thinking about is a way that we could produce a type of snow drought real-time monitoring system or tool, and that's something that we'd also be excited to hear your thoughts on how we could do that and how that would help any of you guys out. So with that, I'll say thanks for having me, and glad to hear any of your guys' thoughts on this.
All right, thanks, Ben. At that time, we're at the top of the hour, but we're going to stay on as long as we can to answer your questions. I'm just going to go down the list. Pop up this. While the questions are, you're taking some time to write them in, I just want to say just a reminder that these slides will be on drought.gov, and we've been producing 2-page summaries of the content from the webinar as well. That makes it an easy way to be able to see what's been going on and the different graphics that we've seen. Our next webinar is scheduled for the end of March. As Alicia mentioned, these are going to be every 2 months. And feel free to contact us if you'd like more information on the Drought Early Warning System or would like to be a partner and become more involved. Okay, so the first question we have is, have we ever determined the rate and process of natural aquifer recharge as a result of high precipitation years? If any of the speakers feel free to answer.
This is Cindy in Sacramento. In California, we are just now beginning to monitor and develop a program for managing our groundwater supplies. So as far as I know, that has never been determined. It also depends on the depth of the wells. We have shallow shale wells in the foothills of the Sierra that are 80 to 125 feet deep. In the San Joaquin Valley, we've got wells that go down to 1,500, 2,000 or greater feet down below. So it depends on the aquifer that you're in. So sorry, not yet.
Thanks, Cindy. Definitely an answer that we were all thinking about, though definitely see that we're getting there, though, hopefully in the future. Next question are, on the east side, I assume the east side of the Sierra is referring to, are normal seasonal water supply volumes so much larger than the west side because they are typically lower, so the increases are more apparent on the east side?
I'm not sure. Can you repeat that question? This is Tim. I'll try to answer, but I didn't quite get it.
Are the east side normal seasonal water supply volumes so much larger than the west side because they are typically lower, so the increases are more apparent on the east side?
Well, the volumes are certainly, in general, lower on the east side as far as the normal volumes. But in terms of, I haven't looked closely at the snowpack on the west side to speak to that, and maybe Cindy can help me out, because I don't know if the snowpack numbers are quite as strong there. We're near record territory for this time of year on the east side, and I think a lot of low elevation snow too that's not particularly well picked up by the kind of the 5,500, 6,000 foot level that's not well represented by the monitoring network. Cindy, do you want to add?
I think your statement as a whole works, Tim. Snowpack-wise, we are seeing, I would say, in the top 20% as far as snowpack across the Sierra. And for your volumes, those are very high as well. I would say volume of runoff on the west side is obviously much greater than the volume of runoff on average on the east side. So yes, you're seeing those larger percentage numbers for runoff, forecasted runoff volumes on the east side because their totals are usually much smaller. But yeah, the west side is the wet side, so we normally get the larger runoff.
But just clicking to the observed runoff to date on the west side, those numbers for this water year are equally or not more impressive than they are on the east side.
All right, thank you. Next, we're getting more into thinking about La Niña. The question is, are La Niña years generally as wet as this year in California, Nevada? Isn't that typically more of an El Niño phenomenon?
Well, back to that graph I showed at the beginning, there's an awful lot of variability, and that's very true in different parts of the state of California. Also, during ENSO, we tend to either El Niño or La Niña. We have a little bit of a stronger signal in the south, so we can say more about the south than we do in the central and the northern parts. So yes, we can look to El Niño and La Niña to give us a range of possibilities and see some tendencies for precipitation or for temperatures, but there is an awful lot of variability. And I think it's really important for people to keep in mind that the records for ENSO have only been going back since 1950. That's not a huge sample size. So trying to make definitive calls on places with that few of samples is really tough to do. So I think we all have to keep in mind the variability. It's quite large.
And I just want to go ahead, Ben. Sorry.
Oh, sorry. Okay. So yeah, just one thought on the El Niño La Niña seasonal type outlook and how that pertains to the precipitation is kind of a good way to think about it, I think, is that one phase or the other will be tending to favor a particular outcome, but it doesn't necessarily, it's not a deterministic outcome that's going to take place, because as we know, all it takes is a couple, 2, 3, 4 storms, and you can, just like we've had, you can drive out of drier period into a very wet period, and that can occur independent of any given phase of the atmosphere-ocean state. So those are, you can think of them in terms of kind of probabilistically favoring one outcome or another, but they're not going to specifically determine it. And I think last year was a pretty good example that things came out a little different than we expected.
Yes.
Yeah, and I just had another quick note is that in the central Sierra Nevada, some of the wettest years in the records that we have, El Nino records, have been weak La Niñas like this one, and which reinforces the point, especially in the central part of the state, Central California, Central Nevada, that the predictability of ENSO for our winters is really not that great in the central part of the state.
All right, thank you. Let's move to the next question, and this one might be a little harder to answer for this group, but are there any predictions you can provide on the presence of coastal fog in California? I think that's getting into a harder scale to forecast that we've discussed here.
Yeah, coastal fog has always been a grand challenge in a lot of cases, and people are still working on it as far as I'm aware, but I think a lot of it has to do with the magnitude of upwelling and the land-sea temperature contrast and the establishment of the ridge offshore of California and driving the favorable fog-forming conditions. But as far as the predictability, I think that's still a pretty challenging and open question.
Okay. One last question, and this is probably for Ben and maybe Dan if he wants to pipe in as well. Is there a better way to determine snow drought than using a single date, perhaps a number and a variance term to indicate departures from it?
Yeah, I think that's kind of exactly the way we're thinking it should go, is that there should be some way to quantify through time how the snow drought has established and changed in its magnitude, and like this year we were in snow drought, and then we came out of it briefly, and then we went back into it, and now we're out of it, and one date cannot accurately capture that, and that's essentially what we're trying to show, is that we probably need to go a little bit further than just one date. And so any ideas on how to do that are definitely welcome and very valuable, and I think that's going to be a really important aspect in incorporating into our evaluations of past snow droughts as well and their impacts, as well as the likelihoods of snow droughts going into the future, and how just a few storms or lack thereof can really make a difference in how a snow drought sets in or doesn't. So yeah, that's a great question. Dan, do you have any thoughts?
No, I think you summed it up pretty good, and just the fact that we don't have a quantitative answer for that yet, but we're definitely heading down that path of not relying on a single date, like Ben mentioned.
All right. I think that was the last of the questions at this time and at the end of the webinar. Thank everyone for listening. Again, join us again in March, and hopefully we'll see how we get closer to the end of the water year date, or end of April. Sorry, the April 1st date. We'll see how we're doing with snowpack, snow water, and drought monitoring. So, thank you.
Thank you.
Oh, thanks everyone.
Oh, yeah, and thank you to all our presenters for joining us today. It was very informative, and we're glad to have you guys on board.